Hello students, welcome to this lecture where we are studying about engineering mechanics subject, and in this particular video we will see how moment of force is calculated. In the previous videos we have seen concept of moment, and now we will see how to do the calculations of moment of forces when different forces act on the bodies. We'll start with very basic illustration. Now here is the rod. Now this question is given. Find the moment of force 20 Newton about point A and B. Now force of 20 Newton is acting at point B, and we need to find out moment with respect to point A and then later with respect to point B. So if you know how moment is calculated, you will be able to do this calculation very easily. But for a beginner, it is important to know how it is proceeded. Now see, this force 20 Newton is coming at certain angle. It is not coming in vertical direction or horizontal directions. So the mathematical definition of moment or the formula is force into perpendicular distance. We have the force 20 Newton in magnitude, but the perpendicular distance for this force, that means if I have to take moment with respect to point A, from point A I need to have a distance which is perpendicular to the line of action of the force. Now this 4 meter is not perpendicular to this line of action of force. So therefore what we do in the calculations where non-concurrent force system is involved, and especially when we have to find out moment of various forces. Now the forces that are coming at angle, okay, that means they are not vertical or horizontal. When they are coming at certain angle, we resolve the forces into their horizontal and vertical components, and then we calculate moment of those forces about given point. Now in this question, this 20 Newton, since we don't have perpendicular distance, that is what we should obviously first check whether we understand, we know the perpendicular distance or not, and that can be easily done. Okay, so we don't have that. So therefore this 20 Newton force is split into vertical and horizontal component, and this is easy. So it is 20 sine 30 downward, this is 20 cos 30 downward. Okay, now we will find out moment of this force and this force, and by taking proper sign convention we will add them. Okay, now this is how it is written. Moment of the force with respect to point A. Now this is the sign conventions to be followed. In the entire subject, I will be using this sign convention, that is clockwise is positive. In some textbooks, or you may follow the reverse, that means clockwise minus also you can take, and that's just a sign convention, and it depends on completely on our assumption. Okay, so now this 20 sine 30 will create, you see how it is going, it will create anti-clockwise moment. It will create a clockwise moment. Now this 20 sine 30 will try to rotate the rod with respect to point A in the clockwise direction, therefore plus 20 sine 30, and now we have the perpendicular distance, that is 4 meter into 4. This is very simple. Now next, again we have to check for this because it has been split into two components, 20 cos 30. Now this 20 cos 30, you see this force is coming in the horizontal direction like this, and if we extend this force, it will go and pass through the same point A about which we are supposed to take the moment. So the moment of this force with respect to point A will be 0, because though we have the magnitude, we don't have the perpendicular distance. Okay, so this force will not try to rotate the rod with respect to point A, so therefore it is 0. So remember this, that whenever a force is passing through a point, and if we have to calculate moment about that point, then it becomes 0. So it is it is 40 Newton meter, and the entire answer, if it is plus, we will write in the bracket clockwise. This is the direction of the moment. Okay. In the second case, that is with respect to point B. So here only we can see that this force is passing through the point B. So moment about point B will be 0. There is no need to split this into two components and again check it, because even if we do that, it will be 0, but it is a straightforward understanding. Okay, Now just one the take one what we are going to take from here is whenever forces are coming at certain angle, we are going to split them into vertical and horizontal component, and then we will calculate the moment. Now here is another example. Now here more than one forces are acting, unlike in the previous question. Find the moment of all the forces acting on the bracket as shown about point A and then about point B, right? So let us see the solution of this question. Now first we will find out moment of all the forces about point A. Okay, that means what is the understanding? If I fix this point A, if I pin joint or make a hinge support at point A, what will be the rotational effect of this bracket because of all these forces? That we have to check. Okay, so that first we will find out with respect to point A. Now see this force, if you see all the forces, this force and this force, they are coming at angles. 20 Newton force is coming in the vertical direction, 15 Newton is again vertical direction. So we don't have much issue with horizontal and vertical forces. This is horizontal force and this is coming at angle. So whenever forces are coming at angle, most of the situation we don't get the perpendicular distance to write the moment value. So therefore what we do is, as I just explained in the previous sum, we need to split this into horizontal and vertical components. So this will be 30 sine 60 vertical component, downward direction because of this is coming in the downward direction, and also it is going the left. So this is 30 left side cos 60. So we have split this 30 Newton into two components. Similarly here also we have to split this force into two components, 40 cos 30 and another component vertical, that is 40 sine 30. Now instead of this 30 Newton which was given in the original numerical, we will be using these two. Similarly here instead of 40 we will be using these two. Okay, and then we will try to see how much moment they create with respect to point A. Now to start, now the summation, we will take summation because there are so many forces. So that is a net moment of all the forces. This is with respect to point A, and the sign convention, the clockwise is positive, is equal to, we'll start with the first force. Now 20 Newton, you see 20 Newton force, it is passing through the same point A. We are checking moment with respect to point A, then this 20 Newton is passing through the same point A. Therefore, it will have zero moment. So it is zero. So it is like 0 plus. Okay. Then I have taken this force 15 Newton. It is 15 into 3, that is perpendicular distance, plus we are not going to take this 30 Newton. As said, we will take these two. So 30 sine 60 is vertical force. Again it is plus because this will create clockwise moment. You have to understand the directions. Okay, it is coming downward, so we have to go like this. Okay, so it is clockwise, so it is plus 30 sine 60 into perpendicular distance is 7. Okay, next plus you see 30 cos 60. Now this force is actually passing through the same point A. Now this component is passing through the same point A. The moment because of 30 cos 60 will be 0. So that is why I have not included here. It is plus 0. Next is 10 Newton force. Again you see it is trying to create the clockwise moment. It will rotate in the clockwise direction. 10. But what about the perpendicular distance? Perpendicular distance is, now this is the line of action. This is the line of action of 10 Newton force. Okay, so somewhere here. Now this is the perpendicular distance. Okay, perpendicular distance to the line of action of the force. So this distance is 3 meters. Therefore 10 into 3. Now this force 40 Newton is split into two components. We will take one by one. Now 40 cos 30, Now this is the line of action of the force. This is the line of action of the force, 40 cos 30, and the perpendicular distance from A to this line of action is 3 plus 2, that is 5. Okay. And the direction, if you see the direction, this force is, if I go from this arrow towards the point A, it is going in the counterclockwise direction. Therefore, I have put minus according to my sign convention. Okay. Next is 40 sine 30. This is the line of action of the force, and the perpendicular distance from point A. I need to go in normal direction, perpendicular direction, 90-degree direction. It is 7. Okay. So therefore 40 sine 30 into 7, and it is minus because you can see it is creating counterclockwise moment with respect to point A. If we do this calculation, minus 56.3 Newton meter, and we should not leave here. We should remove this sign, either plus or minus, and put it in the bracket. According to our sign convention, it is clockwise. So this is more significant than this. Okay. So now all the forces will rotate this bracket in the counterclockwise direction with this much of magnitude, 56.3, when we hinge point A. Now next is, if we hinge point B, if we hinge the point B, then you see we'll take the forces one by one. Now 20 is the magnitude of the force. The perpendicular distance with respect to point B is 3 plus 7, and it will create anti-clockwise moment. That is minus 20 into 7. It is easy to understand. Okay. Then this 15 Newton force, the perpendicular distance from this point to this point, it is 4. Therefore 15 into 4, it is minus, because that will also create anti-clockwise, plus this force 10 into 3, it is clockwise. See, it is going like this, it will go like this, and the perpendicular distance is 3, it is 10 into 3. You see, I have not considered 30 Newton force, because the 30 Newton force will not create any moment with respect to point B, because it is passing through the same point. So moment because of 30 Newton at point B will be 0. So therefore that will not come here. Then this force is left 40 Newton. Again, this is split into two components, as we have already done. 40 cos 30 will have negative moment. See, it is going like this. Now this direction is anti-clockwise, so therefore minus. So it is minus here. The perpendicular distance to the line of action is 5. This distance is 5. So 40 cos 30 into 5, of course it minus is there. Then I have not considered this. This will not come, because this force is going through the same point B, and it will have 0 moment. If we evaluate minus 343.2 Newton meter, that means 343.2 and counterclockwise. So if we hinge this point B, if we make a pin joint at point B, then the rotational effect is 343 in the counterclockwise direction. This is also counterclockwise, this is also counterclockwise, but this is more in magnitude, in value, compared to this. Okay, that means if we want to have a higher rotational effect, we have to pin joint B. That means in given two option, either A or B, we will pin joint B for higher rotational effect. Okay, and if we want less rotational effect in the given option A and B, then we will make a hinge at point A. Okay, so this is how moment is calculated. Now these are a few examples which I have taken in this particular video. We will be solving more problems on coplanar non-concurrent force system, especially where we will find out the resultant of given force system. Then we will study the Varignon's theorem. Then we will use how Varignon's theorem is utilized to identify exact location of resultant. There the calculation of moment plays very important role. Okay, so thank you for watching this video.